lines of position or LOP, or celestial lines of position or CLOP. Well, these are also called as astronomical lines of position or position lines. So let us talk about position fixing on Earth. Suppose this is an object, that is lighthouse, and we take the bearing. We can fix the position of the ship. Well, if we have this bearing of this lighthouse from the ship, then the ship will lie somewhere on this line. Similarly, if we take the distance from the lighthouse and the distance is equal to the radius, we'll have a position circle, and the vessel will lie somewhere on this circle. Well, the navigational computations require angular measurement, and that measurement is in degrees and minutes of the arc. Now, this arc could be on the Earth surface or on the celestial sphere. However, both the spheres are concentric. The angular distances are transferable from one sphere to another sphere. Say the Earth is at the center of celestial sphere. This one is the celestial sphere, and this is the radius, which is taken as infinite. Now let me talk about this horizon system. Suppose this is the Earth, and this is the center of the Earth. Let me mark here. Well, from the center of Earth and the observer, let's say the observer is here on the surface of Earth, we join the line, and wherever it meets the celestial sphere, that will be called as observer's zenith. So that means the observer is here at this point, and this is the observer's zenith on the celestial sphere. Similarly, this is the celestial body, and from the center to the celestial body, it will meet somewhere on the Earth surface. This is the rational horizon, which means that this is the horizon which passes through the center of the sphere. So this is the center of the sphere, and this is the center of Earth also. Well, the position of the celestial body on celestial sphere can be transferred on the Earth surface. So here we have this angle, which is altitude. From rational horizon to the body is called altitude. Well, from body to the observer's zenith is the zenith distance. Since this is the arc and the measurement is an angular measurement, so from H to Z, this point, we have this 90 degree. So if we know the true altitude, we can easily find the true zenith distance. Let me reinforce here. This is the zenith. This is the center of the celestial sphere. This is nadir. And these are the vertical circles. Vertical circles are the circles which join zenith and nadir. And this is the rational horizon. That is how it will look. And this is the Earth. So celestial body is here. That is X. That is the celestial body here. So the altitude of celestial body will be from rational horizon to the body. Similarly, the zenith distance will be from body to the zenith, this one. So we can bring the position of celestial body, that is geographical position, as I had defined the geographical position here. This is the geographical position. The line joining the center of the sphere and the celestial body cuts the surface of Earth at some point. That is the geographical position. This is the geographical position of celestial body, and this one is the zenith distance. Well, this is the circle on the Earth surface, and this is called position circle. 90 degree to this azimuth. Well, this is the azimuth, that is the angle which is made from north, and 90 degree to this azimuth is the position line, and the observer will lie on this line. Well, the distances are very large, so this arc is also very large, so we can take tangent to this, and this is called position line or a line of position or CLOP. Now let me define azimuth. Suppose this is a rational horizon diagram. We are talking about this red color rational horizon, and this is how it looks here. This one is the north point, this one is the south point, this one is east, and this one is west. This is the observer centric, so observer is in the center. Well, let me also mark here that this is from north to observer, this is 90 degree, and from south to observer or from observer to south, this is also 90 degree. This one is also 90 degree, and this one is also 90 degree. Well, this is the equinoctial WQE, this is equinoctial, and this one is the latitude. As the earth rotates west to east, body will appear to travel from east to west like this on this declination circle. Suppose the body is here at this point X, so this distance from horizon, and this is the rational horizon from here to here, this distance is the true altitude. From celestial body to the observer, that is the zenith distance, and this is the arc of horizon. So that is rational horizon. So this is the north and south line. The angle made from this north-south line, that is the observer's meridian. This is the vertical circle which passes through the observer and the celestial body. Like this, these are the vertical circles which is passing through the observer and which is passing through the observer's zenith and the celestial body. The circle passes through the zenith and another. So this angle is called azimuth. Well, the position line will be 90 degree to azimuth. So here this is the position line and this one is the azimuth. So position line is 90 degree to azimuth. So these are the methods of obtaining celestial lines of position. One is latitude by meridian altitude, one is intercept, and then longitude by chronometer or x meridian or altitude of Polaris.